Yeah.
Okay, so the investigation, the first question was for us to plot this so that we can see the effect of the coefficient. I think by now we should know the effect of these numbers, right? What is the effect of these numbers?
Makes it go closer to the y.
That's not how you would say it.
Dilates. It dilates it horizontally. It's a horizontal dilation.
I can't hear you.
There's a horizontal dilation.
It's a horizontal dilation. It causes horizontal dilation. Again, Alex, I don't want to call your name before you participate, and same with Yanko. So let's see. Before then, let's see what happens to x to the power 4. So from what you have investigated, you realize that x to the power 4 is always flat at that turning point, right? Always flat. So if you have negative x to the power 4, what will happen? It's going to flip it. Okay? It's going to reflect it in the y-axis. What if I have minus x to the power 4?
Nothing will change.
Nothing will change. Why?
Because
It's
it's an even function.
Because it's an even function. So, and this is meant to be a reflection in the what?
X-axis.
So when this curve reflects in the x-axis or y-axis?
Y.
When it reflects in the y-axis, it's the same thing.
Yes, yes.
Okay? Please answer the question. Don't drag so much, and I don't want some side comments, please. Thank you. We don't have time. So that's the first one. So let's have a multiple of all these. One over 6. Clearly we can see that there's a stretch. Okay? It's meant to be, when you have a multiple, that's a vertical stretch, right? So the original function, let me put the original function in a dotted line, like that. This is the original function. This is the original function. So you could see, for the 2, let's focus on this. When you have 1 here, here you have what? 2. So stretched by 2. Here you have 0, 0. Here you have, let's say, 1.43. But if you go up, 1.43 times 2 will be 2.8 something, right? No. 3.9, that's like 4, right?
Yeah.
Then the other one should be around 8. So here, this is 4. Then if this is when x is equal to root 2. Okay, let's pick something on the line. Okay, let's take x is equal to 1. You can see y is equal to 1. Then this is y is equal to 2. Alright, so it's a stretch by 2. But look at this. This is 1. Right?
Yeah.
And this is 0.5. Okay? For 1 over 6, same thing. So the smaller the number, what can you say? The closer to the x-axis. So it becomes more flat. Okay? And the bigger the number, the farther away it is. So if I have this as 200, can you see that?
Yeah.
Okay? It becomes narrower. Okay? And it's going to come through the origin 0, 0, of course, for x raised to the power 4. So, of course, the negative will just be the same thing, but flipped in the other direction. Is that not?
Yes.
What does this do? Translate by
Horizontal.
by horizontal. What does that mean?
Horizontal translation.
It's an horizontal translation.
On the x-axis.
You don't need, it's
You
horizontal.
don't need horizontal translation is already there.
Oh yeah.
Alex, please focus. If you need some time to cool off down outside, you are free to do that. But please, I need focus. I don't want this, I'm so tired, I'm so frustrated feeling in my class. I want a positive energy, and I want full concentration. Thank you. So again, I want someone to reply this properly. What can you say about this? What is the connection between this and these two?
horizontal translation
Mm-hmm.
by the number in the bracket.
I don't know what that means.
By, there's no variable to
Yeah.
say.
Pick the first one.
Okay, by 2 units to the right.
Okay, if that was your response in the exam, I'll give you 0. Yes, I want a proper response.
Translation by the vector
Mhm.
-2, 0.
That's it. Now, it says, what is the significance of A? Who wants to comment on that? Significance of A. What is the significance of A?
Vertical stretch.
A corresponds to a vertical dilation of the curve by the scale factor of A.
A corresponds to vertical dilation by scale factor of A. You lost me there. Because that sentence doesn't really make sense to me.
Just the size of it,
X to the power 4.
No, no, no. What is the significance of A? Focus on A.
A is the vertical, is the scale factor
Good.
of vertical dilation
Of the
of the original of
the scale
X to the
factor
power
of
4.
scale factor of
A. No.
A is the scale factor of
X to the
vertical
power
dilation.
vertical dilation.
the vertical dilation, not x to the power 4.
Yeah.
Yes, complete the statement
Of the function.
of the function. I don't understand what is wrong with those that always keep quiet in my class, and it's getting to the point where I can't take it anymore. Describe how this graph is obtained from this. How this can be obtained from this. What did you write? Anyone? Stop putting him under pressure. If he wants to respond, let him respond. Anyone?
The graph
Mhm.
y equals to a open bracket x minus b close bracket to the power 4.
Mhm.
Wait, no, the graph is a translation by the vector b over 0, b0
Mhm.
from the graph a to the power 4, x to the power 4.
So it's just retranslation. There's no dilation there. Question B. There are types. So here I wrote 7 types. Did I put 7 types?
Yes.
Is it 7 or 6?
7.
Okay. A, B, C, D, E, F, G. Okay, yeah, 7. The first type is when you have 4 distinct linear factors. You expect it to have 4 intersect, right, on the x-axis. So let's see, 4 distinct linear factors. So maybe x minus 1, of course there will be a, right?
Yep. Yes.
X minus 2, for example. Oops.
Mr. Ando, should you have the variables inside as letters as well, so you can just slide them across?
Because it's just one type. Okay, yeah, maybe we should. Okay. Like we did over the weekend.
Yeah.
So x minus b, x minus c, x minus d, and x minus e.
There isn't one for E.
Did I miss anything?
There's no one for
So,
A.
yeah.
There's no e. Or because e is
Yeah.
probably seen as exponential. So this is everything 1. So this is more or less x minus 1 raised to the power 4. That's y. So let's change it. You come here. A can be positive. Let's see first. So you come here. So we have maybe 2 positive, 2 negatives. Something like this. Okay, that's one of them is too long. The C maybe. Yeah. And can you see?
Yes.
So there will be 4 points of intersection. And if your A is negative, then it's just going to turn around.
Yes.
Okay. And your A determines how stretched it is. So if I have higher A, it will be longer. And of course, if I have negative also, it will be longer. So the closer it is to 0, the less stretched it is. Understand? So if you have 4, this is what you have. Now, you say effect of A. When you change the sign and size of A, what is the effect?
When A is positive, and as A increases, it stretches, the graph stretches, but as A is negative, it reflects along the y-axis. No, I mean the x-axis.
Along the x-axis. When A is negative, it will flip.
Yes.
Even you said when A is positive, it stretches. Are you saying when A is negative?
No,
it
no, it
doesn't
also
stretch?
stretches. I didn't.
Yeah. Okay, it stretches.
Yes.
Whether positive or negative, it just flips. All right. So basically, when A is positive, you can see the two turning points are below, and one turning point is above. So it has 3 turning points. But if your A is negative, it's the other way around. Okay, something like this can be a composition, something like that. Then in terms of the sign, it flips it, of course. Okay, quickly, significance of this 4, in this case, this B, C, D, F.
It tells the x-intercept.
The x-intercept, so they are responsible for the x-intercept. All right, so let's remove 1. The second type is when you have both, okay, 1 square, right? 1 square. So let's remove this and square this. F is gone, so you go. So let's see, move it close. I think my A needs to be checked, so it's not too stretched. Okay, so something like this, so that we can see. Okay, so what do you notice?
One of
The
the
graph touches at the square.
The square point is where it touches,
Yes.
right? And this is not new to us. In the cubic, we notice the same thing. It's meant to have 4 intersects, but one of them, it won't cross, it's going to touch. That is the square one. Okay? So that is on B. So if our B is 1, it's going to touch on that 1. Something like this. Touch here. Okay? And if it's negative, it's just going to flip. Oh yeah, this is negative, this is positive. Okay, it will only touch 3 places. It will have 3 intercepts, touching at 1, crossing at 2. And when you have both square, can somebody guess before we do it?
square, they will have two
Touch at
touches.
2 points.
It's going to touch at 2 points. Okay? Will it cross?
No.
Okay. So what does that tell you? Either all the curves are above
Or
or
below.
all the curves are below. Is that not?
Yeah.
Yes.
So let's increase this A. You see?
Yes.
So if it is negative, the other way. Okay, it's going to touch, not cross. So again, you have that. So this is, I think, type. So the same question, the effect of A, alpha, and beta, right? So we know that A is going to stretch it by how much it stretches, okay, on the positive or negative axis, and alpha and beta is where it's going to touch. And all the part of the cover either above or below the y-axis. So if you have 1 cube, again, there should be 2 intersects. There should be 4, right? But then we have just 2. Because one of them is a cubic. And what do you notice about the cubic one? That's where it is flat. Remember about the cubic function? It's flat like that. So if you have this lower, for example, see here, there's no D anymore. Get out. You see, that's where it's flat.
So
Okay.
what would that point be called?
It's still x-intercept. You still have your x-intercept.
So no, but like, is there a name for it? Because you know, it crosses, it touches, and it.
It crosses.
So you would just say it crosses.
Yeah, it crosses at 1.9.
So there's no special word for it.
Except
Flat.
we can say it's a point of inflection or something.
Okay.
Under calculus, a point like that, we have, I think it's a stationary point of inflection because the gradient will be 0. Okay?
Oh.
But there's no change in direction because it goes down and it's continuing to go down again. Okay. Now, what if all are 4? I think we have seen this already.
Yes.
If all are 4 is just going to be so flat at that point, and it's going to just touch, not cross. Okay? Because the moment it crosses, it's meant to come back, right?
Yeah.
And it cannot come back. Once it comes back, it has 2 points of intersection, and it's not supposed to have 2 points of intersection. Okay, so now, what if you have 2 linear and 1 quadratic with discriminant negative?
What about the turning point when she touches it?
So it will touch twice, and you're meant to have 2 more, right?
Yeah.
So what will happen to the other 2?
It's not.
It's a
It's a.
it's a curve that tends to the x-axis, but it turns.
It doesn't touch the x-axis, but it's going to tend to x-axis, but we never touch it. So let's have a format like that. So let's say x squared plus bx plus c.
You have 2
Yeah,
C's.
I know. So maybe x minus d, x minus f. So now our b must be such that it is lower than c. C must be positive. C must be positive. So maybe 1 to 10, for example. Step 1. Our b can be anything. So I will say minus 5 to 5, just for simplicity. Step 1. So if I want a discriminant that is negative, if discriminant must be negative, b squared must be lower than 4ac, right?
Yep.
Yes.
So let's say our c is large enough. Is b squared lower than 4ac yet?
Yes.
Yes. But then 2 things are equal. Okay, these are not supposed to be equal. Okay, something is not right yet.
Should
Can
you
you?
zoom out?
Yeah.
What have I not done?
I think you just need to zoom out. It's.
No, that's not it. Okay, so there's an intercept. Hold on. Let's change this to all integers. Minus 5 to 5, step 1. F also minus 5 to 5, step 1. Okay, let's do the same for A. 5 to 5, step 1. Okay. Now, my D, let's say my D is 2, and my F is minus 1. So those are the 2 intersects, right?
Mm-hmm.
My A, let's keep that as positive for now. Then my B square is 4 minus 4AC. That will be 4 times 4, 16, right? So this should be it. But it's too much. So it's going to cross here. That's just 2. Yeah. Okay, but I was expecting something. So it's just going to cross at 2 points. Did you get anything different?
We get some.
Get something that doesn't touch.
Yeah.
I was expecting something like that.
Maybe make A1 and then zoom out.
Okay, let's make it 1. Yeah.
try to zoom out and see if there's anything
Looks like
above.
there is a
It
point
looks
of-
like there is at
There's a point of
negative 7.
inflection somewhere.
Yeah.
There's a what?
There's a point of
Uh,
inflection
why-
under the
yeah.
x-axis somewhere.
Well, y is negative
It's not-
7 about
It's not
time.
going straight up, there's
Yeah.
a little bit of
It's
Yeah.
just a bit of
If I increase this,
Can't tell what exactly.
Which means there's a curve right there because it's heading in that direction. Now it's
Yeah.
that way.
now there is.
so no, that this becomes square.
Go
Yeah,
back.
now
Because b
it's
square
zero.
minus 4ac here is 0.
Just make,
Now it's
So this is when your discriminant is greater than 0.
Yes.
just make C's bigger.
So
There is.
we can leave it here. This is 9. 4 times 4 is 16. So we can have something like that. So, so it's not going to turn like we thought. It's just going to give us 2 roots. That's it. So this quadratic doesn't have any effect whatsoever then. Do you understand? You can see what happens. Just cross at one point.
It's not.
Do you get my point?
Yeah.
Yeah.
Because I was trying to do, remember what we did yesterday?
Yes.
So if you have this, for example, so I was expecting this quadratic to give me a point where, like this.
Yeah.
Ah. So, last one. If both are, so this might be where we will get it. So, let's see, b squared minus plus, what is that now? dx, right? dx plus f. Okay, do we have all the variable in the slider? Yes. So I think this is okay. So let's do the same for d.
Is for
So
just
negative
make
f
f
will be
bigger,
increased.
yeah.
yes. Now there's negative.
Positive definite.
So you see the same shape, it doesn't just touch. Okay? And if a is negative, it's just going to become negative definite. Does that make sense?
Yes.
Yes.
Alright. So, and it's not going to cross. So this is our observation. Now, quickly, this is a summary of what we have. If you have single factors, again, if a is greater than 0, it's going to open up. Less than 0, it's going to open downwards. So this is a greater than 0, a less than 0 will be the other way around. Okay? Now, if you have all squared, all single factors, everything will cross in 4 places.
Yep.
If you have a cube factor, the cube will be here, while the other one will be here. The cube will give us the shape of a cubic curve. Are you paying attention?
Yes.
If you have one square factor and 2 linear factors, so that means 3 factors, 3 points of intersection. So the 3 points of intersection will be there, but the square factor will not cross. It's just going to touch. Okay? So please let's take note of that. And here, you see, it depends. Depending on the number, right? So you might have in the order of arrangement, maybe the first 2 are linear with no square, then you have this. Maybe the third number, 1, 2, 3. Are you getting it? If 3 is where you have that, so you have to remember that for you to have this here, this must actually cross first. Hello, can you get a difference between these 2?
Yes.
Yes.
So it's like having 1, 2 square, and 3.
Yeah.
But why this is like 1, 2, and 3 square?
Yeah.
So we need to get that. Now if you have this, it's going to be super flat. Depending on the value of A, whether to be narrower or will continue to be wider. Okay? And when you have all cubed, don't forget that. If one of the discriminants, you have this. So this is what I was expecting. Unfortunately, maybe because of the way our construction is also. Okay? So if these 2 can have, then the other one will not. Okay? And finally, if both of them cannot, you have this. This is just a summary. So again, do you want me to print this summary and you stick it in your note, or you just form a note from this yourself?
I think sticking it on notes will be better.
Sticking will be better?
Because
Okay,
we
so
might miss something if we write it down. Like that.
Okay, so I will print this out. Do you want me to do the same for the cube that I asked you to form a note?
Oh, yes,
But
please.
there's a
Yes.
formula. No.
You form a note for that? Who hasn't formed a note?
The rest of
Lazy boys.
Sorry.
Only Yanko is a good boy today.
Yes.
Yes.
He didn't hand in the homework.
Right.
That's the old me.
Yanko!
That's the old me. Hey, Connor handed in late, okay?
At least I handed it better late than never.
Okay, only Alex handed it.
Right.
Alex is the most
Okay.
responsible.
So let's
Really
listen to this. That's okay.
That was the most handed.
Let's listen to this. So we want to see what the sketch will look like. Before we play it, let's try to analyze it ourselves. What shape do you think this will give? It's going to be upward or downward in terms of opening?
It's gonna be
Upward.
It's going to open upward because clearly the coefficient of everything is positive, right?
Yes.
It's gonna
Then it's going to have how many points of intersection?
free.
Free.
It's gonna cut twice and touch
Cut
once.
twice
Touch
and-
one.
And
Touch one.
touch one. Touch
And
one.
touch once.
Yes.
So where are those points where it's cut or touch?
2 over 3,
negative 3,
negative 1.
So arrange in order on the number line. Which one is the first?
Negative 3, negative
Negative
1.
3,
And then
It goes
touches.
through.
negative 3, come down,
Okay.
yes.
Negative 1,
Negative 1,
positive 3 over 2.
positive 3 over 2.
2 over 3.
Okay. So where does it touch? It's going to touch here.
Yeah, touch
Yes.
that one.
And it's going to cross here. So if it touches here, you have something like this. Because it said it's opened up, right? So if it open up, actually it should show
Should be
this.
like
Okay,
the
not the
other
other
side.
one. Okay. If it open up, then you have something like this.
Yes.
Mhm.
Then, yes.
Something like that. Then go back. Okay. The y-intercept will be what?
1 times 3 times negative 2.
So what's that? Negative 6. So y-intercept is negative 6. So this is minus 3. 0 will be somewhere here, right?
Yeah.
So you have something like this, where this is negative 6. Okay? So these basic ideas should be easy to sketch, right?
Yeah.
I'm not even sure we captured that, Elsin. Supposed to be our super cameraman.
Oh, yeah.
Hiya.
Hiya.
So just show that so that, zoom in on that, and so that when we're watching later, we have it. Then come back to the screen. Done? Quickly, we have 10 minutes. Ready?
Yeah.
Okay, let's play this. Oopsie.
It's close.
Okay.
It's close. The voice is close.
You mean
Just have to click the icon on the
Upwards
side.
or downwards. We determine the sketch. In this example, we sketch the graphs of quartic functions which have been written in factored form. With the quartic, it is useful to know whether it opens upwards or downwards. We determine this using the sign of the leading coefficient. In part A, the leading coefficient is 3 times 1 times 1 squared, which is positive. The quartic opens upwards. We see that the quartic has 2 single linear factors and a squared linear factor. The graph cuts the x-axis when these single linear factors are 0. So, it cuts the x-axis at x-intercepts minus 3 and 2/3. The graph touches the x-axis when the squared linear factor is 0. So, it touches the x-axis at x-intercept minus 1. We find the y-intercept of the graph by substituting x equals 0. The y-intercept is minus 6. We sketch the graph by marking the intercepts and drawing a smooth curve through these points. Since the quartic opens upwards, we start with our pen above the x-axis. Remember that the graph touches the x-axis at minus 1. In part B, the leading coefficient is minus 1 times 1 squared times 1 squared, which is negative. The quartic opens downwards. The quartic is the product of 2 squared linear factors. It will touch the x-axis when these factors are 0. So, it touches the x-axis at x-intercepts minus 2 and 3. We find the y-intercept by substituting x equals 0. The y-intercept is minus 36. We sketch the graph by marking the intercepts and drawing a smooth curve through these points. Since the quartic opens downwards, we start with our pen below the x-axis. Remember that the graph touches the x-axis at minus 2 and 3.
That's easy, isn't it? Please make sure you label your graph. You don't have to write it on it, I won't advise. But label appropriately. Okay? Yes, quickly.
Based on like the distance between the second intercept
Mhm.
with the other two, we can tell
how the depth of the
This
of the curve.
Yes, we can. We can. So you need to, just use your initiative at that point. Look, of course, it's going to be a minor thing to be observed, but you don't have to calculate turning point or whatever. We're not there. Yes, quickly.
So with the vertex of that thingy, of the parabola half thing,
Not
would it be
parabola, but a curve.
like the curve? Would it be in the middle of those 2 points, or is it different for quadratic?
I mean, this
Yeah, those -3 and -1 with the
the
turning
vertex.
point. With the turning point of that little bit
This one or
be
this
at negative. No, so like the intercepts are at -3 and 1,
Mm-hmm.
right? So would the turning point of this part, no, the one that goes like that,
Mm-hmm.
yeah, would that be at -2? Or
No,
no,
no. Because it's not symmetric. It's not symmetric. We don't have a data that suggests it. It's not symmetric. Okay? So a good question there.